Okay, so today we are talking about volume of prisms. In order to find the volume of a space figure, you need to determine if it is a prism. So we've only been talking about prisms. Prism has to have two congruent parallel bases. The volume formula is the same for all prisms. So you'll notice this page has a rectangular prism, this one's another rectangular prism, two triangular prisms, and then at the bottom even a trapezoidal prism. The formula is the same because it's a capital B, which is area of the base, times the height of the prism. So for each one of these, we need to find the area of the base, and we need to be able to identify the height of the prism. That means you won't need the green highlighter that you were using for surface area. So area of the base means that we have to identify which side we're going to use for the base. So on this one, I used the 6 by 13, the top. That's this work here, length times width because it's a rectangle. And then the height of the prism, which goes from the top to the bottom, is 14. So the height of the prism, you'll notice that I substituted over here. Area of the base, where we did 6 times 13 is 78. Area of the base times the height, and you get the volume. It's really that easy. So let's take a look at the one over here. If I were to shade in this side over here that already looks sort of gray, if I were going to call that my base, for example, it would have dimensions of 5 by 21. This side is 5, this side is 21. So let's start with area of the base. It's a rectangle, so we would do length times width. Area of the base would be 21 times 5, so it would be 105 inches squared. You also need to have the height. We said that the height connects one base to the other base, so in this case it would go horizontally from one base to the other, and so in this case the height would be 6 inches. And then we could simply plug it into that same formula, area of the base times the height. So volume equals, and you'll notice it's a capital B and a capital H. Capital B for area of the base, capital H for height of a prism because it's three-dimensional. So we got 105 for the base, and the height is 6, making the volume 630 inches cubed. All right, so we move on to the triangular prisms. They are triangular prisms because the bases are triangles. I'm going to use, in both cases here, the shaded triangle as the base. So this is the one that I would, color in yellow to say what's the area of the base. The base is a triangle, so we use 1/2 BH. The base being along the bottom here is 15. The height, notice it's a lowercase h because it's the height of just that triangle, is 9. So 1/2 times 15 times 9, it's 67.5 feet squared. That gets plugged into our formula, area of the base times the height. Now the height connects the prism in the front to the prism in the back, so the height is 7 feet, and that goes here. And we get our answer, 67.5 times 7 is 472.5 feet cubed. So if we go over to the one where we have to actually write the numbers in ourselves, we will use this triangle as our base, and that's capital B. So the area of the base, green. Area of the base is 1/2 BH because this shape, this prism, has a triangle for the base. So 1/2. Lowercase b is 15, lowercase h, height of the triangle, is 7. Area of the base is going to be 52.5 meters squared. Overall, we would find the volume of the prism to be capital B, capital H, area of the base times the height. So we got 52.5 times the height that we identify. Goes from one base to the other base. The height is going to be, in this case, 18 meters. So we would multiply the 52.5 by 18 and get the volume of that triangular prism, 945 meters cubed. Pretty straightforward. No one's going to argue that volume of a prism is faster and easier than surface area. All right, so if we slide this up, you can see we've even got a trapezoidal prism here. Turn the word trapezoid into an adjective, trapezoidal prism. The trapezoidal prism can be a little bit harder sometimes to decipher because there are more lines. So again, you've got this one that's sort of shaded here in the back. We're going to treat that one as our base. I know it's the base because there's a trapezoid in the front and a trapezoid in the back, and they are congruent. Now, when I look at that trapezoid, I have to identify base 1 and base 2. And the parallel sides in this one are the top and the bottom. So we've got a short top that is 6 and a long bottom that is 12. So that's our base 1 and our base 2. We've also got a height of the trapezoid that's 7. So the height of the trapezoid, not to be confused with the height of the prism. The capital H height of the prism is going to be this 5, because it's going to go from the trapezoid in the front to the trapezoid in the back. So capital H here is 5, and lowercase h is the 7 meters. So when we go to plug this in, first thing we need is the area of the base. You'll notice I've added the formula here for base of a trapezoidal prism is the formula for trapezoid. So area of the base is going to be 1/2 base 1 plus base 2 times the lowercase h height of the trapezoid. So 1/2, I've got to add the 6 and the 12 since it's in parentheses. Half of 18 is 9 times 7, so the area of the base is 63 meters squared. When I go over to our volume formula, which is the same formula for all prisms, we have the area of the base, 63, times the capital H height of the prism front to back, and it is 315 meters cubed. So volume, not terribly difficult. If we flip this over, you can see that we have a couple just, practical ones that don't look quite as mathy as the ones on the front. And these don't have anything shaded. So I didn't identify what you need to use for the base. Most people, when they look at a rectangular prism, most people are going to pick the top. Doesn't matter. You can pick any side on a rectangular prism to be your base, but most people choose the top because that seems to be the most straightforward. Makes the most sense. So we are going to start with area of the base. It's a rectangular prism, so we use length times width. So area of the base is going to be 10, which is this side, times 20. So that is 200 yards squared. And then the height of the prism is going to be that top to bottom, the distance from one base to the other base. So our capital H is 14. So we're going to have to do volume equals area of the base times the height. So that's going to be 200 times 14. So 200 times 14, really easy to do 2 times 14, which is 28. And then put the put the 2 zeros on there, 2,800 yards cubed. Volume measured in units cubed. Now, last but not least, a triangular prism. This triangular prism has a triangle in the front, triangle in the back. You can highlight whichever one makes more sense to you. Most people, I think, on this one would probably say that the front is a little bit easier to see, but you can use either one. Area of the base, our base is a triangle, so we need to make sure that we use the formula for area of a triangle this time, which is 1/2 BH, not the same formula as a rectangle. Along the base is 4, the lowercase h height of the triangle being 1.5. So area of the base is 1/2 times 4 times a height of 1.5. Half times 4 would be 2 times 1.5, and the area of the base is going to be 3 meters squared. The height, going from front to back, 6 meters. So capital H, going to be 6 meters. Volume of the prism, area of the base times the height. Volume is going to be 3 times the height 6, or 18 meters cubed. Pretty straightforward, guys. Volume should be pretty smooth. It goes quickly. And tomorrow we will talk about volume a little bit more. Thanks a lot. I will see you soon. Bye.